Okay, good morning. What I will do in this video is to review what we have discussed in our class about the differentiation formulas and relate it to our topic chain rule. Okay. So as you can see, in our class, we discussed the following differentiation formulas: the derivative of a constant, which is 0, derivative of x to the n is n x to the n minus 1, derivative of e to the x is e to the x, derivative of sine x is cosine x, derivative of cosine x is negative sine x, derivative of tangent x is secant squared x, derivative of cotangent x is negative cosecant squared x. Derivative of secant x is secant x tangent x, and derivative of cosecant x is negative cosecant x cotangent x. I wanted to relate it to our topic, the chain rule. The chain rule actually is a generalization of this formula as it describes the derivative of functions which are results of the composition of two functions. For example, you have a function h of x which is described as the composition of f and g. Okay, f and g. Our objective in the chain rule is to find the derivative of this kind of function, which is the result of the composition of two functions. And if you read the materials, the handout I sent you in iStudy, it says there that the derivative of h of x, okay, is actually the derivative of f of g of x times the derivative of g of x, which serves as the argument of your f. Okay. If you look at this definition, it looks to be quite complicated, no? But if you assign u to g of x, then this function h of x can be written as f of u, which appears to be just a simple function, right? So to find for the derivative of that, we simply find the derivative of f of u. But according to the chain rule, since u is another function, you have to find for the derivative of that. So what we're going to do is to perform the derivative of u. Okay, and we denote that by this expression. It says the derivative of h of x, which is the composition of f and g, is the derivative of f times the derivative of its argument, which is u, or g of x. So if we relate that chain rule to our differentiation formulas, of course, for the derivative of the constant, we don't have problem with that. But for number 2, the more general formula for this is written now as the derivative of, instead of x, we have u, okay, raised to n, which is equal to n u to the n minus 1 times the derivative of our u. Okay, yeah. So u to the n is the composition of two functions x to the n and another function described by that q. So that's what happens when we use the chain rule, no? For number 3, you can write that as the derivative of e to the u times is equal to e to the u. But don't forget to find the derivative of u. This is the derivative of sine u. So you see, the argument now for sine is u, which is a function of x. Can be written as cosine u. So just follow the formula, but don't forget to find for the derivative of u, which is derivative of u, and so on and so forth. Okay, we can write the more general form of these formulas by using the chain rule. Watch for my next video, because I'm going to discuss some examples that is similar to the problems I've given in exercise.